In today's class, we will go forward to study about J.J. Thomson model, Rutherford alpha scattering experiment, and even discuss about the discovery of neutrons. Till now, only two subatomic particles were discovered, that is electron and proton. And whichever experiment or whichever process was conducted, it was conducted on the basis of only presence of electrons and protons. Now, after the discovery of electrons and protons, J.J. Thomson modulated his first theory for atoms. No doubt there is that the first fundamental theory was made by Dalton, but that was a complete failure after the discovery of electrons. So after the discovery of electrons and protons, the first fundamental theory for atoms was given by J.J. Thomson. His theory, this model is also known as plum pudding model or watermelon model. In his theory, he said that atoms are nothing but atoms are made of positive spheres with electrons embedded in it. I'm sure everyone have seen watermelon. When we cut it in two equal halves, we see that the red portion. What J.J. Thomson did was, the red portion of the watermelon he represented as the positive charges, and the seeds he represented them as the electrons. So according to him, an atom is a sphere made up of positive charges with electrons embedded in it. He also said that atoms are electrically neutral. However, many experiments conducted after J.J. Thomson modulated his theory, not a single experiment could prove that J.J. Thomson's atomic theory is correct. They had a doubt on J.J. Thomson's atomic model. So, one scientist named as Rutherford, he wanted to try up an experiment in order to prove whether J.J. Thomson's atomic model is true or it is not true. So, during those days, Rutherford performed an experiment. Now we will discuss about Rutherford's alpha scattering experiment. During those days, alpha scattering experiment was considered to be one of the most expensive experiments. Yet, Rutherford was able to do this experiment only because in those days he was already working with radioactive elements. That is the sole reason he was the only scientist who could perform alpha scattering experiment during those days. Let us see the setup of alpha scattering experiment. In this experiment, he took a box in which he placed some alpha particle source. He also placed a lead plate. The main purpose of this plate was to concentrate all the alpha particle beam towards the gold foil. A gold foil was placed which was as thin as the paper. And at the back of this gold foil, a U-shaped screen of zinc sulfide was placed. It was a fluorescent screen. Now, alpha particle was allowed to shoot and hit the gold foil. Now, based on this, some observation was made by Rutherford. Rutherford and his co-worker performed this experiment. So, the observation which was made by this experiment was that almost 99.9% of the alpha particles happened to pass through the gold foil and hit the screen. They were passing in a straight line. Almost 99.9% of alpha particles happened to pass through the gold foil and hit the screen. Only few, very few alpha particles after hitting the gold foil passed with some deviation, making certain angles. Only few, that means only 1 out of 20,000 alpha particles, after hitting the gold foil, they bounced back. How was it possible for Rutherford to know that some particles are bouncing back? It will not be shown in your textbook, but they also placed one more fluorescent screen at the back. That is how they came to know that some alpha particles are bouncing back and hitting back the screen. Only one, that means out of 20,000 alpha particles, only one alpha particle happened to go and strike back. Now from this observation, some conclusion was made by Rutherford. The first conclusion which he made was that he also compared J.J. Thomson's model with his experiment. According to J.J. Thomson, positive portion is scattered everywhere. If J.J. Thomson model was true, alpha particle also has positive charge, and we know that like charges repels each other. If J.J. Thomson experiment model was true, some of the alpha particle, not some but most of the alpha particle, after hitting the gold foil, they will not pass through the gold foil, but there will be repulsion and they will hit back. But the experiment conducted by Rutherford, what happened was almost 99% of the alpha particle happened to pass through the gold foil. So from the first observation, he concluded that most of the portion in atoms are empty. This is why, just because most of the portions are empty and it does not have any charge, 99% of the alpha particles could pass through the gold foil without any disturbance. Now, few of the particles which pass through the gold foil making some deviation, he assumed that they passed very close to the center, that is the positive charge. He assumed that this few alpha particle rays, the beam which deviated with some angle, passed very close to the center. That is why because of the repulsion, they happen to deviate by some angles. And 1 out of the 20,000 alpha particle which bounced back, it was assumed that it passed directly through the center. Since it passed directly through the center, because of the repulsion, it bounced back. Because we clearly know that like charges repel each other. So the alpha particle positive charge happened to repel the positive charge in the atom, and the 1 out of the 20,000 alpha particle happened to bounce back. Now, based on this experiment, he made a model. That means his postulate he have written down or formulated in a model. So his first postulate was that an atom has empty space around it and the positive region or the positive portion is concentrated only to a very small region, that is at this center. According to J.J. Thomson, positive charges are distributed evenly. But after this experiment, it was concluded that positive charge is just concentrated at this center and it is not evenly distributed. And this positive portion, it was named as nucleus by Rutherford. So Rutherford is credited for the discovery of nucleus. The second thing which he said in his postulate was that electrons are revolving around the nucleus in a circular orbit. This was the second thing which he said, that electrons are revolving around the nucleus in circular orbit. The third thing which he said was that the electrons and the nucleus are held together by electrostatic force of attraction. Now the question arises here is that if they are held together by electrostatic force, and if suppose the electron is stationary, what will happen is, since opposite charges attracts each other, the electron will come and hit the nucleus, and as a result the atom will be destroyed. But this electrostatic force of attraction is converted to centripetal force. Here electrostatic force becomes equal to the centripetal force. Electrostatic force upon conversion of centripetal force helps the electron to move in a circular orbit. Anything that moves in a circular orbit, it is circulating because of electrostatic force. So these are the things which was formulated in alpha scattering experiment, and this experiment was a major breakthrough in the field of science. It provided varieties and numerous information about atoms. But as it is said, with every experiment there comes some drawbacks. So Alpha scattering experiment also had some drawbacks. The first drawback was that it explained everything about atoms, every possible information he provided in his model, but he could not explain the stability of atoms. He also could not explain the line spectrum of atoms. Line spectrums we'll be studying under spectrum topic in details. So this was the two drawbacks of alpha scattering experiment. No doubt that it was one of the major breakthrough in the field of science, but it also came with some drawbacks. So till now, alpha scattering experiment, J.J. Thomson model, only the presence of electrons and protons were known. Till now, the third particle, it was not discovered. So every assumption, every theory that was formulated, it was based on the presence of only electrons and protons. Now, still the scientists, they were not very much convinced. They were not happy with the existence of atoms because there were always some calculation mistakes, and they were wondering what must be the additional particle which is responsible for the entire mass of an atom. Till then, the scientists, they were not very convinced with the existence of atoms. So during those days in 1932, a scientist named Chadwick, he was also a very curious kind of a person. So what he firstly did was, he wanted to weigh two atoms. So he took, in a weighing balance, in one side he took helium, and on the other side he took two hydrogen atoms, because we know that helium has two protons and hydrogen has one proton each. So in order to make the weight equal, if we take two hydrogen, that means it will be two protons here and two protons here. So logically it should weigh the same, but when he checked the weight, it was found that helium was much more heavier than the two hydrogen atoms. According to logic, since we are taking two atoms versus one atom, they should be heavier. But experimentally it was found that helium to be much more heavier than these two hydrogen. So from here he was a little disturbed. He was wondering, why is this happening? So from here he thought that protons and electrons will not be the only contribution to the entire mass of an atom. There must be some other particle which is contributing to the total mass of an atom. So he performed an experiment which was somewhat similar to alpha scattering experiment. In his experiment, he took one alpha particle source. He also selected three elements that were lithium, beryllium and boron. Alpha particles were allowed to bombard in these three particles, and it was found that some radiation emitted and struck off the paraffin. Paraffin was also selected. It is some kind of wax type. So upon hitting the paraffin, it hit the paraffin so hard that atoms started bombarding from the paraffin. Now just imagine you are to fight with a very fat person. If you are very lean, you will not be able to fight with that fat person. You need to be very fat, you need to be equal in weight in order to push that person. So from here, Chadwick, he concluded that whatever may be the particle, it will have the same mass as compared to proton. If it did not have the same mass, there is no possibility that these rays will go and hit the paraffin so hard that the protons will be ejected. So he concluded that. He also observed that this very particle emitted, it had mass but it did not have any charge. And from here, since it was hitting the paraffin so hard, that he also concluded that this beam or this particle will have mass which will be equal to proton or slightly higher than proton. So from here, the mass of the neutron were calculated. That means it was found to be similar to that of the proton. So it was 1.67 into 10 to the power minus 27 kg. And he also observed that there was no charge in this particle, only mass was present. So this very particle was named as neutron by Chadwick. So this is how the third particle was discovered. And with the discovery of this third particle, it made a very big positive impact in the field of science. Whatever we study today, we are studying about electrons, protons and neutrons. So the discovery of neutrons, there were many experiments done, many processes followed in order to find how these electrons, protons, and neutrons they are arranged in the atoms. And in today's date, we have quantum mechanical model of atoms which provide us with every necessary information, every details about atoms, whatever we want to know, they provide us. So with this, we come to know that how the subatomic particles were discovered, how J.J. Thomson modulated his model, how alpha scattering experiment came into being. So I'm sure by now it will be very clear how all these things were developed or discovered. Also, do not forget to answer some of the questions which will be displayed. And if you have any queries, you are always welcome with your questions. And I hope we will meet in the next sessions with more interesting topics. Till then, take care. Thank you.